Dear students, very good morning. Today we are going to discuss some important problems under inverse Laplace transformation. The first problem is find L inverse of find L inverse of 1 divided by s square plus a square into s square plus b square. And the second problem we are going to see is find L inverse of a square divided by s square plus a square into s square plus b square. So these two problems are very important under inverse Laplace transformation. So we are having we are going to find the solution of first problem. The solution here can be taken by using positive fraction. So we are considering 1 by s square plus a square into s square plus b square, that is equal to a divided by as plus b divided by s square plus a square plus cs plus d divided by s square plus b square. Okay, then we have to find the cross multiplication value, that is we are going to take LCM. So s square plus b square into as plus b plus s square plus a square into cs plus d equal to, see here we are having s square plus a square into s square plus b square. This is equal to 1 divided by s square plus a square into s square plus b square. So we can have s square plus b square of as plus b plus s square plus a square of cs plus d equal to 1. So in this you have to equate the coefficients of equating the coefficients of s cube, s square, s and constant. So here what will be the coefficient of s cube? So see here, the coefficient of s cube will be given by s square into as and as well as s square into cs. So the coefficient of s cube will be given by a into s cube. So coefficient of s cube will be a, here c into s cube, so it will be c. So a plus c equal to 0. In the same way, coefficient of s square will be given by s square into b as well as s square into d. So you will have b plus d equal to 0, because in the right hand side you are not having any s cube term or an s square term, so their coefficients are 0. Okay, third thing is coefficient of s will be given by this b square as well as a square cs. So you will have a b square plus c a square equal to 0. Okay, finally you are going to take your coefficient of s square. Okay, finally you are going to take the coefficient, the constant term. So the constant term will be given by b square b constant. Constant is given by b square b, okay, plus a square d. Here constant is 1. Okay, so from this you will can say c equal to minus a. C equal to minus a. In this you will have d equal to minus b. D equal to minus b. Okay, in this you can write c equal minus a, d equal minus b. So you will have a b square minus a square equal to 0. You can take a commonly outside. So b square minus a square equal to 0. Here b not equal to a. Definitely b is not equal to a because the variables are different, which implies b square minus a square not equal to 0. Therefore what will be 0? A equal to 0. A equal to 0. C, we can say c equal to minus a means c equal to minus a means c is also equal to 0. C is also equal to 0. Okay, so now we can substitute in a positive fraction 1 divided by s square plus a square into s square plus b square can be written as cas plus b divided by s square plus a square plus cs plus d divided by s square plus b square. Here the values are given by a equal to 0 and c equal to 0. So you will have 0s plus value of b is you have to find the value of b. So how to find the value of b? See, the value of b can be given by constant. Okay, so from the constant you can have b square b plus a square d equal to 1. Here you can have b square of b minus a square of b equal to 1. You can take, because d equal to minus b, you can take b commonly outside. B of b square minus a square equal to 1. Already I have told you b square minus a square is not equal to 0. So they are not equal. So b equal to 1 divided by b square minus a square, which means d equal to minus of b minus b. That implies d equal to minus 1 divided by b square minus a square. Okay, so here you will have 0s plus value of b is 1 divided by b square minus a square whole divided by a square plus a square plus c will be 0s plus 0s plus minus 1 divided by b square minus a square divided by a square plus b square. So that is equal to 0 will be cancelled. So you will get 1 divided by b square minus a square is commonly outside. You will have 1 divided by a square plus a square plus minus, it is minus 1 divided by a square plus b square. So here you have to take the LCM, 1 by b square minus a square of a square plus b square minus a square minus a square divided by a square plus a square into a square plus b square. But you have to know one thing, is there any use of taking LCM? Nothing. So we can remove this step. Before that, you can directly take the inverse Laplace transform. We can directly take the inverse Laplace transform. So here you can write 1 divided by a square plus a square into a square plus b square. Therefore L inverse of 1 by a square plus a square into a square plus b square equal to L inverse of 1 by b square minus a square into 1 divided by a square plus a square minus 1 by a square plus b square. Okay, now here by linear property you can take 1 by b square minus a square outside, and you can write L inverse of 1 by a square plus a square minus 1 by a square plus b square. So it can be further written as L inverse of 1 by a square plus a square minus L inverse of 1 by a square plus b square. 1 by a square plus b square. Okay, so you can have 1 by b square minus a square of 1 by a square into 1 by a. You must have 1 by a divided by a square minus plus a square. L inverse of mine, because this is the structure that we require to write it in the formula of sin AT. So this is minus L inverse of 1 by b into b divided by a square plus b square. So here you will have 1 by b square minus a square of, by linear property you can take 1 by a outside, L inverse of a by a square plus a square minus 1 by b into L inverse of, okay, L inverse of b divided by a square plus b square. So your solution will be 1 by b square minus a square of, this is sin AT by a, this is minus sin bt by b. Okay, so this is the solution that we require. But you can also write it as 1 by b square minus a square of b sin AT minus a sin bt divided by ab. So this is our L inverse of 1 by a square plus a square into a square plus b square. So now we are going to our next step. The second problem question is, before taking second problem question, we shall highlight this. We should highlight this. Okay, the second problem question is find L inverse of s square divided by s square plus a square into s square plus b square. So this is our second problem. So how to solve this? So let us do the problem. Here consider s square divided by s square plus a square into s square plus b square equal to as plus b divided by s square plus a square plus cs plus d divided by s square plus b square. So you will have as plus b into s square plus b square. Okay, as plus b into s square plus b square, then plus cs plus d into s square plus a square whole divided by s square plus a square into s square plus b square equal to s square divided by s square plus a square into s square plus b square. Okay, this is what you are having now by partial fraction. Okay, so it will imply as plus b into s square plus b square plus cs plus d into s square plus a square equal to s square. Okay, so now you are having like this. So with this we can continue or see, listen, with this you can equate the coefficients of s square and everything, but see here this is one method. Okay, so here you can equating the coefficient of s cube, s square, s and constant. You will get a plus c equal to 0 for s cube. For s square you will have b plus d equal to 1. This is for s square. For c for s you will have for s you will have for s you will have ab square plus ab square plus ca square equal to 0 and for constant you will have bb square plus da square equal to 0. Okay, this is for constant. Okay, here you can see c equal to minus a. You can see c equal to minus a, and here you can see a equal to 0 as in the previous problem, and b square minus a square not equal to 0. Okay, similar to the previous problem. So here you are having b equal to 1 minus b. Here you can take, see, I shall explain it step by step. Here you can say a b square minus a square equal to 0. you can take a common answer. So b square minus a square equal to 0. So a equal to 0, which implies c equal to 0. Here you can see b plus d equal to 1. So b square plus the value of d is 1 minus b. 1 minus b a square equal to 0. So you can expand it as b square plus or minus b a square plus a square equal to 0 plus a square equal to 0. So here you can take b of b square minus a square equal to minus a square. So b equal to minus a square divided by b square minus a square. Okay, therefore d equal to, see here, d equal 1 minus b. So d equal to 1 minus b, which implies 1 minus or 1 minus a square will become a square divided by b square minus a square, which implies d equal to b square divided by b square minus a square. So you are having this as the value of d, this as the value of b, and you are having a equal to 0 and c equal to 0. You can substitute these values in the following. That is, you can have a square divided by a square plus a square into a square plus b square equal to as plus d divided by a square plus a square, then plus cs plus d divided by a square plus b square. You can substitute the values here, which implies a equal to 0, c equal to 0. So b equal to means you will have minus a square divided by b square minus a square divided by a square plus a square. Then cs will become 0. For d you are having b square divided by plus b square divided by b square minus a square divided by a square plus b square, which implies 1 by b square minus a square can be taken outside. So you will have minus a square divided by a square plus a square plus b square divided by a square plus b square. So the result will be, here the minus is excess, so L inverse of a square divided by a square plus a square into a square plus b square equal to 1 by b square minus a square of here you should have only minus a, and here you should have only b. So you can write it as minus a into a divided by a square plus a square plus b into b divided by a square plus b square. So for everything you are having L inverse. For the complete thing you are having L inverse. Okay, so this is one method. I can also teach you the simplest way to solve this problem. That is equal to L inverse of 1 by, see this by linear property. By linear property you can take 1 by b square minus a square of minus a L inverse of a by a square plus a square plus b into L inverse of b by a square plus b square. So from this you can have 1 by b square minus a square of minus a sin at then plus b sin bt. So the final result is L inverse of a square divided by a square plus a square into a square plus b square equal to b sin bt minus a sin at divided by b square minus a square. Okay, so this is the result. But it can be also written as a sin at minus b sin bt divided by a square minus b square. Okay, now we are going for another method, another way. See, we are going to solve the problem by another way. So take down the problem once again. A square divided by a square plus a square into a square plus b square. Okay, so the problem is another method, by another method we are going to solve. So L inverse of, okay, again we are going to solve it. L inverse of our second problem. Okay, L inverse of a square divided by a square plus a square into a square plus b square equal to L inverse of a square plus a square minus a square. I am adding and subtracting a square divided by a square plus a square into a square plus b square. Okay, this can be written as L inverse of a square plus a square divided by a square plus a square so the problem is, okay, a square plus a square into a square plus b square, okay, minus a square divided by a square plus a square into a square plus b square. Okay, now this is nothing but L inverse of, these two terms will get cancelled, 1 divided by a square plus b square, okay, minus a square divided by a square plus a square into a square plus b square. So this can be written as L inverse of, by linear property we can write L inverse of 1 by a square plus b square minus I can take this a square outside, a square outside, and I can write L inverse of 1 divided by a square plus a square into a square plus b square. Okay, now I know the value of these two. Okay, see, L inverse of 1 by a square plus b square means I should have b. So 1 by b into b divided by a square plus b square minus a square L inverse of 1 divided by a square plus a square into a square plus b square, a square plus b square, a square plus b square. This can be written as see 1 by b L inverse of b divided by a square plus b square minus a square L inverse of 1 divided by a square plus a square into a square plus b square. Okay, that is equal to 1 by b L inverse of, see, this is sin bt, 1 by b sin bt minus a square into, I know the value of this from the first problem. From the first problem we can write L inverse of 1 by a square plus a square into a square plus b square equal to the value is a sin, see the value is b sin at minus a sin bt by ab into, okay, 1 by b square minus a square equal to 1 by b square minus a square into b sin at minus a sin bt, b sin at b sin at minus a sin bt divided by ab. So I am going to substitute that value here. I am going to substitute the value. So a square of a square of 1 by b square minus a square into b sin at minus a sin bt divided by ab. Now you can write it as 1 by b sin bt minus this square and this a will get cancelled, so you will get b sin at minus a sin bt whole divided by b into b square minus a square. Now I have to take the LCM for these two, which implies b square sin bt minus a square sin bt minus b sin b sin, here there is a, okay, yes, here there is a, so it will become a sin and a square minus ab sin at minus of minus will become plus a square sin bt whole divided by b into b square minus a square. Okay, now now the two terms will get cancelled. That is minus a square sin bt, and this plus a square sin bt will get cancelled. See, this is like this. Okay, so minus ab plus a square. Okay, now you can write it as, you can take b commonly outside, b of b sin bt minus a sin at divided by b into b square minus a square. These two b will get cancelled, so this can be written as a sin at minus b sin bt divided by a square minus b square. Therefore our answer is L inverse of a square divided by a square plus a square into a square plus b square equal to a sin at minus b sin bt divided by a square minus b square, So this is the required solution. So here I have shown you the two method of calculating the value of L inverse of s square divided by s square plus a square into s square plus b square. Okay, so go through the video. Okay, I think the lecture will be very useful for you. Okay, so thank you all for watching this video. Thank you all once again. See, I am showing the solution here. Okay, the solution we have obtained here. Is same as that of the last solution, a sin at minus b sin at. Okay, a sin at minus b sin bt by a square minus b square. Here also you have the same solution, a sin at minus b sin bt by a square minus b square for L inverse of s square divided by s square plus a square and s square plus b square. So you can use either of the two methods. So thank you all for watching this video. Thank you all once again.